Initially when Earth formed, correct, all of you know, Earth was formed along with the solar system 4.54 billion years ago. I told you Earth was formed due to clumping of gas, dust, minerals, rocks due to mutual gravity. Correct? You saw the video. All the rocks, gases, dust and all, they clump together. So Earth as a planet is a congregation of gases, dust, minerals and rock fragments. You can write this down if you want, okay? But write in some other page, next page. Earth is a congregation of gases, dust, minerals, rock fragments, correct, which have coalesced, which have combined or coalesced due to mutual gravity. So Earth contains gases, dust, minerals, rock fragments which have combined, which have clumped due to mutual gravity. So initially Earth was formed around 4.56 billion years ago. It was in a hot molten state. It was in hot molten state. Hot means what? Temperature very high. Molten means what? Semi-solid. Semi-solid. Mixture of both. Okay. Semi-solid. Hot molten state. Please notice this, all of you. This is the Earth. So what happens when the planet is in molten form? Notice this. The denser minerals like iron, nickel, correct. All these denser minerals will come down because their density wise very high. They will all accumulate in the center, forming core. Okay, which contains nickel and iron. All the denser elements came down. Why? Because Earth was in molten form initially. That molten form allows the movement of minerals based on density. So all the denser elements came down. Lighter elements like silica, alumina, oxygen, gases, hydrogen and all came out. All the gases were here. Minerals of low density came up, forming crust. Okay, now all of you know. So how various layers were formed. Crust is the outermost layer of low density minerals and gases. Low density minerals and gases. Core is the innermost part of the Earth having higher density minerals. Okay, because of molten state. In the middle was mantle. Mantle here. Crust, mantle and core. Okay, so like this 3 layers were formed. This kind of movement of minerals where lighter elements came out, denser elements went in. Mantle contains both. It is a mixture of both lighter and denser. This kind of movement is called as density segregation. Density segregation. This topic will come again. What is segregation? Separation. Let's say in the first day of the class, you will be sitting in random chairs, whichever chair you got. But after a week, you will know each other, same PG, same district, same state. You will become groups. Have you noticed? From then on till the completion of all the classes, you will be holding chairs for your friends. You will be a group in the class, like a pressure group in the class. Correct? Like that. Though Earth also, initially, it was random arrangement. Slowly, they all got separated, forming 3 layers, crust, mantle, core. This is called as stratification of the Earth. Stratification of the Earth. So this is how 3 layers were formed. So we are all living where? On the crust, which contains low density minerals and gases. Core is where? Inside, which contains higher density, nickel and iron. Mantle consists of ferroaluminosilicates. Ferro, iron, alumina, alumina, silica. Ferroaluminosilicate. Don't worry, I'll write again. This topic will come again. My interest is this core now. The core contains nickel and iron in large quantity. So this nickel and iron are ferromagnetic minerals. Inside Earth, there are certain minerals which are natural magnets. Naturally behave like magnet. So cobalt, lodestone, nickel, iron, these are all ferromagnetic minerals. Ferromagnetic minerals are those minerals which naturally behave like magnets. Inside earth we have many. Iron we have, nickel we have, cobalt we have, lodestone we have. All these are ferromagnetic minerals. Among this, which are two most popular? Iron and nickel. Where do we have them in large quantity? So the core behaves like a magnet. The core of the earth behaves like a magnet. So there is a magnet inside the earth called geomagnet. So now you got an introduction. Okay, what is happening now? So inside the earth there is a big magnet here, magnet like a dynamo shaped magnet here inside. The core, inner core behaves like a magnet. Okay. Can I go back now? Write this first. So this sign of segregation took place slowly because earth was in hot molten state. Slowly earth will cool. Which part of the earth will cool? Outer or inner? Outer part will cool because it's in contact with space. So this became hard, but still this inside parts are still hot because the heat is not conducted completely. Earth contains more non-metals than metals. Overall composition of earth में, next class I'll tell you, next topic में, most of the minerals inside the earth are non-metals. So non-metals are poor conductors of heat or bad conductors of heat. As a result, the inner regions of the earth are still hot. They are unable to conduct that heat out. You got it? The heat is trapped inside. So that's the problem with this. Okay. So this heat is slowly coming out. I'm not saying it is not. Slowly it is moving out. So wherever it gets space, it comes out. That is causing earthquakes, volcanoes, plate tectonics and all. That is the driving force for all this. That is happening on the earth's surface. We'll discuss that slowly. For now, my intention is to tell you that there is iron, nickel where? Inside. Those are what? Ferromagnetic. They are natural magnets. These are natural magnets. Okay. So earth के अंदर we have a magnet now. This is a magnet. Imagine a bar magnet type magnet. Every magnet will have two polarities. So north and south. So every magnet will have magnetic lines of force emerging from north always, converging south. Correct? Like this. These magnetic lines of earth start from where? Inside. Go up like this. And these magnetic lines of force don't converge with each other. You can see how I am writing. They start from inside. They go up to 60,000 kilometers in space. 60,000 kilometers around earth. Okay, beyond our atmosphere, into space. This magnetic field of the earth, what we are talking about, is called as magnetosphere. So the magnetic lines of force start from inside and go up to 60,000 kilometers in space. This field around earth is called as magnetic field. And it's also called as magnetosphere. This magnetosphere protects earth from solar wind, solar flare, solar plasma coming from the sun. For now, you remember this much. In the next class, geomorphology class, I'll tell you about other topics which are related to this, like aurora borealis, aurora australis, how auroras are formed. All that topic will come later. For now, you remember there is a magnet inside. And this magnet has magnetic lines, which you can't see, but we are all surrounded by this. Even you take two magnets, le lo, opposite polarities you keep, they'll attract. Opposite polarities. Like polarities you keep, it will repel. So opposite polarities attract, like polarities, it will repel. So you can't see that there actually, but you can feel it. Even though that magnetic field you can't see, but you are able to feel when you hold two magnets in your hand. Okay, do that next time. Or already you have done it as a kid. Right? Played with the magnet and all. You have seen how magnet works and all. So you are unable to see, but you can see how they behave. So the magnet inside the earth has a huge magnetic field protecting earth from solar wind, solar plasma and all. So that is the reason some of our satellites, space stations, astronauts who go into space, correct? They also they get a protection from the magnetic field of the earth. Only when our satellites go beyond our magnetic field, then they need another protective sheath layer to protect themselves from the solar wind, solar plasma. This I'll show you now. This part I'll show you because difficult to imagine. See, this is like this. There is a magnet inside, you can see. Red color is north polarity and white is south polarity, like this. You can see the magnetic lines of force around the earth. This is what I was trying to write. But you know how it is, how the magnetic field looks like. Okay. So I want you to make sure that you remember this. Now, see, this is sun. This is solar wind, intense plasma. This is earth here. Can you see a small, like peanut size planet here? Earth, we are here. This is the magnetic field I was trying to tell you. The magnetic lines of force. This is protecting the earth from the solar plasma. For 1 minute, imagine, what if there was no magnet inside the earth? What if there is no magnet? No magnetic field. What will happen to earth? Because of the solar wind or solar plasma, if it reaches earth, everything gets vaporized. Atmosphere goes first, water bodies go, trees, plants get vaporized. Fraction of a second, because the plasma brings in extreme amount of heat. So that will vaporize the entire planet. Within seconds, will all vaporize. There will be no life. Correct? So the magnetic field, what we have, is protecting us. It is the guardian of the earth. It is protecting us from the plasma. So you can see most of it is going out like this. Like a shock wave. Can you see the shock wave here? Diverted out. So our magnetic field is protecting us from the intense plasma. So only in some places, you can see the plasma gets embedded in some places like this. Here, like this, it gets embedded. Otherwise, it goes out like this. Only in some places, small amount of radiation comes in and gets part of the magnetic field. It gets become part of the magnetic field like this. We call it as Van Allen belts. Van Allen belts, that we'll discuss separately. Van Allen belts are low intensity radiation that gets embedded into our magnetic field. So small amount of it comes towards the polar region here and here, forming aurora borealis, aurora australis. Okay, we'll see display of light, colorful light in the polar sky. Correct? Arctic and Antarctic here. So we'll discuss that separately, separate topic. Okay, it will take almost 1 hour for me to discuss this. For now, I want you to remember what is this called as magnetic field. It is protecting the earth from solar wind or plasma. Okay. Mercury, Venus, which are closer, they have a smaller magnet inside them. So they don't have that much intense magnetic field. What? No. Rocks, for example, they are on solid state. The temperatures are not that much to vaporize the rocks. Na? They are near to the earth, near to the sun. But the thing is here, for example, Mercury comes here, Venus comes here. For them, the amount of, they have their own faint atmosphere. Mercury has a very faint atmosphere. Since it is too close to it, Mercury's atmosphere is also gone. It has very faint levels of gases. But Venus atmosphere contains carbon dioxide. So whatever heat it is reaching the Venus, it is absorbing the heat inside the Venus atmosphere. That is reason Venus is the hottest planet, not the Mercury. Even though Mercury is close, Venus is the hottest planet because of the carbon dioxide present in its atmosphere is capable of trapping the heat. Okay, then comes our Earth. We are protected by the magnetic field. Then comes Mars. Mars also lost its magnetic field very recently, around 10 million years ago, because of which all the life on Mars was vaporized. So that is the reason Mars has carbon footprint. There is a carbon footprint on Mars, but actual life doesn't exist now. Once upon a time, Mars also had some life forms, bacterial mostly. It had. Now it has been lost because Mars lost its magnetic field. We'll come to that. We'll discuss that slowly. For now, just remember this. So, solar wind brings intense plasma from the sun during sunspot activities, for example, or prominence. So, a lot of heat comes out from sun. We call it as coronal mass ejection. So, all that heat goes where? Into the solar system. So, we also receive that from the sun. All this will come again. Whatever words I am using will come again when we discuss sun. Okay, for now, please don't worry. We are still discussing Earth. I thought of putting this image in the notes, but I couldn't happen because of the. I'll check how we can add that image. For now, all of you got it? 7. These are called as 7 Goldilocks conditions for life. What are the 7 conditions we need for life to evolve? These are the 7. For example, if I look at a planet now outside the solar system, if I have to check if there is life, I have to look for how many conditions? 7 conditions. So these 7 conditions, if that planet fulfills, so then it can have like Earth-like conditions. It can have life of its own. So if they ask you the question, why do we have life on Earth? Again, you have to write 7 points. Okay. Why we have life? Okay, please remember that question we are answering. Why we have life on Earth? Not on other planets. Correct? We don't have life on other planets. Why we have? How many points? 7. You have to. 7 conditions of life. You know. So please remember this. Now you know why Earth is a unique planet. How are we different from others? So such a complicated phenomena, right? We have a right amount of gravity, neither too high nor too low. Correct? We are in the right location. What are the chances? See, try to understand the chances here. The chance factor here. Any slight change in Earth's gravity, things would have been different. Any change in the location of Earth with respect to Sun, things would have been different. So everything went well. Correct. The perfect conditions we have. So that is the reason as a, let's say, Earthlings, we are all Earthlings because we are all part of the Earth. So we have to make better choices. Not only for us, for our planet also. We should not think that all other planets, all other plants and animals are for us. We should consider them also as Earthlings and protect them also. Okay. So the choices we make will decide our future. So that we have to do. Be very careful when it comes to the choices we make. So that is the reason I am saying we don't have any other planet. Correct? If we destroy this, we are also going to go extinct here. We are going to destroy ourselves. So that is the reason geography as a subject is taught generally for the UPSC or for any competitive exams or in general to the students to create awareness about our planet Earth. Correct? So that when you get into service, you at least can control the politicians on one side also and see what is better for the planet Earth also. Correct? We can't say we can't go for economic development. Economic development is also important. Our surrounding environment is also important. We have to take a balanced approach. Civil servants, that's what is required. Development also and nature also. We have to balance it out. So that is the reason we are trying to understand all this from the development perspective. So now come to the topic now. I was discussing this earlier. How 3 layers were formed. Crust, mantle and core. So due to density segregation, this led to the formation of 3 layers. Correct? And I told you, Earth was initially in the hot molten state. Any doubt in this? So which part of the Earth will cool? I told you outer layer will cool. Like this. I'll write this diagram again because I don't want to disturb this page. Earth was initially hot molten state. All the minerals, denser minerals came down, forming core. It contains nickel and iron. all the lighter elements, gases, minerals came out, collected on the surface, correct, forming crust. Mantle in the middle. 3 layers were formed. So all of you know this. Crust, mantle and core. So all this happened because of density segregation. So denser elements center, lighter elements out. So slowly Earth started to cool. This part of the Earth started to cool. Because this is in contact with space. So it started to cool. This process is called as degassing. The cooling process of the Earth is called as degassing, where the Earth outer layer started cooling. So there were initially volcanoes also. Volcanoes, large number of volcanoes across. I am writing triangle for volcanoes. Correct? On the Earth there are many volcanoes. What are volcanoes? Basically, volcanoes are also heat transfer mechanism actually, if you notice. What do volcanoes do? They emit molten material out, correct? Magma to the surface called as lava. There is a heat coming out actually. If you notice, volcanoes are basically heat transfer mechanism. The Earth inner heat is transferred out. During this, that molten rock comes out, gases come out, dust come out, correct? All that gases, dust that comes out from the volcano, see, from the volcano, gases and all, dust and all, will go where? Into the atmosphere. So that's how a blanket of air was formed. Because of the gravity. What if the Earth's gravity was very low? All these gases would have escaped. All these gases would have went up. Because of sufficient gravity, all this encircled the Earth, forming a blanket of air that we today call it as atmosphere. So atmosphere formation ke liye we need degassing, cooling process first, volcanoes, Earth gravity. If Earth gravity was very low, all these gases would have escaped into space. Escaped into space. So 3 process led to the atmosphere. Notes, sir. Okay, see, the topics are evolving topics. I am going slowly. Only thing is you have to write one by one. See, I am continuing from the previous topic. All you have to do is, definition already I have given you here. Atmosphere. So atmosphere is a thin blanket of air, correct? And now I am telling you how it is formed. This topic will come again also. Don't worry. When I discuss climatology. If you're finding it, topics are going like this. So because all these topics are going to come again in the advanced topics. So write that down till now. I'll take. Can I continue now? Done? So atmosphere was formed due to degassing. This is a cooling process. Then volcanoes. Then Earth gravity. Volcanoes transfer the heat, dust, gases. All that becomes part of the atmosphere. So don't you think all this, when it happens, the Earth's surface will cool? So Earth's surface will cool. It will contract, become hard. Lithosphere. This hard outer layer is called as lithosphere. What is lith? Rock. Lith means rock. So when the Earth cools, the outer layer will cool. Inner layer remains hot. The outer layer becomes cooler. So minerals will contract. Lava and all will cool, contract, becomes hard. So lithosphere. So I'll write the definition. Outermost hard shell of the Earth. Hard shell of the Earth is called as lithosphere. So lithosphere consists of, see, crust mainly and small part of mantle also. I want you to see this. All of you see the board, please. This part. Crust and part of the mantle. So I am increasing the thickness. It contains crust and small part of the mantle. Some places, wherever the volcanic activities were very large, amount of volcanoes have occurred, thickness is very high, crust thickness is very high. Like this. See, thickness is very high. So thickness of lithosphere changes here. Some places thicker, some places is thinner. Like this. So lithosphere is the outermost hard shell. It consists of, please write, crust. 1 second, I'll reduce the thickness. Crust and uppermost mantle. Crust and uppermost mantle. Like this. Lithosphere is this part, outer part. Don't you think during the volcanoes, during the degassing process, lot of heat is released? Vapor is also released. Vapor. So all that vapor here that is released here, you can see the blue color lines I have given. All that vapor will go up, will cool, condense to form clouds. As it goes up in the atmosphere, it will condense to form clouds. So this is how Earth slowly evolved. Starting Earth was formed, segregation took place, crust, mantle, Earth core was formed. Slowly the outer layer was cooled, forming atmosphere. Then gradually the outer become hard, lithosphere. So the vapor went up, condensed to form clouds everywhere. Clouds. The clouds one day will precipitate water back to the earth, rain, we call it as. All that water will fall where? Earth, back on the earth. Why? Because of the gravity. So where will the water go? See here all of you. The water will fall on the top of the mountain. Correct. It will flow down. Correct. Because of the slope. Finally it will accumulate where? In the depression here. If I put the water here, let's say if I pour the water here on top, where will the water go finally? It will come down. Correct? So gradually all the water came down, settled in the depressions. Wherever we had depressions, wherever we had low-lying points got submerged with water, forming hydrosphere. So slowly the water also came on earth like this, rain, all that water accumulated from rivers, lakes, sea, oceans were formed, forming hydrosphere. All the water on earth comes under the word hydrosphere. It's a very broad term. So now you know, okay, earth was formed first day, solar system, then earth formation, inside earth what happened, then lithosphere, atmosphere, hydrosphere. So don't think that first day only we came. No, slowly we all evolved. It took us time. Okay. So three words: lithosphere, atmosphere, hydrosphere. So we have all the water on earth now. So that is the reason you notice every river takes birth on top of the mountain, comes down, finally into the depression. You take Kaveri river, Krishna river, Godavari river, all the rivers you take, Ganga you take, they all come down from the mountains. Correct. Finally they go down into a depression. Have you seen any river going from the ocean like this back to the mountain? No. Correct. All rivers start from the mountains down into the depression. Because of the slope, they come down. So it will all accumulate here, forming water. So this all water on earth comes under the word hydrosphere. Hydro. Okay. This is dihydrogen oxide. Dihydrogen oxide. All water on earth comes under the word hydrosphere. So water is a wonder molecule. It is a basis of life on earth, correct? Water is life. Without water, we can't, even photosynthesis doesn't take place without water. So as a result, it's a basis of life. Life. So please remember, air and water. So like this, three formation: lithosphere, atmosphere, hydrosphere. First we discuss lithosphere. Lithosphere में land. We are all living on land, correct? And part of above earth we have atmosphere, correct? Part of atmosphere. Then we have water, hydrosphere. Three elements I am taking: water here, air here, correct? Land here. Three elements I am taking here. You can notice this part of the atmosphere. All of you notice the part of the atmosphere here containing vapor and most of the life sustaining gases is troposphere. The first layer of the atmosphere where the life exists is troposphere. Okay, please remember this. Part of the earth's surface, lithosphere, interacting with our water, correct? That is uppermost part of the soil, pedosphere. 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 So the part of all these three which supports life is biosphere. Biosphere. Bio. Part of all these three which supports life actually. Okay. All this part of our environment, right? Ecosphere. Our environment, ecosphere. Troposphere you can write here also, because the atmosphere which interacts with the water also, that layer is also troposphere. First part of the earth's surface. Done? All the three parts. Pedon means what? Soil. Okay, pedon means soil. Okay. Tropo means change. The first part of the atmosphere above the earth is called as troposphere. Okay. First layer of the atmosphere above the earth is troposphere. Every second we are breathing air. Breathing in, breathing out. From which layer? Troposphere. We are walking on the soil every day. Pedosphere. Soil layer. Okay. Part of the water, see here, part of the water is frozen in the form of ice, cryosphere. Please write cryosphere. Part of the water is in solid form, which is frozen in the form of ice, is called as cryosphere, like Arctic, Antarctic region, Himalayas, Alpine regions, they're all cryosphere. So have you heard of cryogenic engine? Cryogenic means very low temperatures. So it's like GSLV engine we have. Cryo means low temperatures. Please write definition. Cryospheres are regions. Cryospheres are regions on earth. Regions on earth. Regions on earth which experience or with sub-zero temperature. What is sub-zero? Minus. Sub-zero temperatures. Regions on earth which experience sub-zero temperature. Sub-zero means below zero. Throughout the year. Please add that. Throughout the year. Means Arctic, Antarctic, Alpine part mountains we have Sub-zero, cryosphere. See, syllabus is a bit vast. So slowly I'll increase the speed. I have to. Otherwise, like I'll not be able to cover a lot of topics. Okay. So what I'll be doing is, whatever I'm writing on the board, I'll be sharing you the PDF. That is one thing you can be careful. So in case if you miss some word also, you can refer the PDF. By the end of this class, I'll give you. So that's what I do. So everything I read clearly write. Otherwise, if some teachers write like this up and down like random, that is difficult for students. But what I do, I write every definition, every word, so that once I give you the PDF here, in case if you are missed, you can refer. So don't worry. So that way the class notes is also given to you. And every word I'm going to write, you can ask your senior batches. So as a result, they'll know. You can mention all this easily. So the formation of Earth, say like we have discussed the syllabus and then topics related to solar system. Okay. What is Goldilocks? 7 conditions of Goldilocks, you know. Earth introduction, you know. Formation of these 3 layers, you know. Okay. So now, right, one small basics we'll cover before we wind up. Important directions. Small topics we'll cover. Cardinal directions of Earth. Okay. So it was Homer, the Greek poet Homer, who came up with this concept of directions. Okay. So he was trying to understand the wind actually. Which direction the wind is coming. So for identifying the wind direction, so he started using the words like north. If the wind is coming from this direction, north wind he called. That's how the directions came. If the wind is coming from the opposite, south, east, west. These were actually words coined for wind direction by a Greek poet, Homer. So in India we use Uttara, Dakshina, Purva, Paschima. These words we use. In Hindi, Sanskrit, local languages, we have used same word, Uttara, Dakshina, Purva, Paschima. These are the 4 cardinal directions of Earth. This you should remember. You can see the first letters, you'll get news. News. So north, east, west, south. What does news stand for? The first letter of all the words is news. Okay. So northeast, west, south. The information we get from all direction is called as news. Every day we use the word newspaper, news channel, correct? That is the information we get from all direction. So notice this now. This is northeast, southeast, northwest, southwest. Other directions. Okay. Poet. Homer is a poet. Remember the first novel of the world, Iliad and Odyssey. He was the author of that, Iliad and Odyssey. Okay, where he talks about the Troy, the one of the ancient kingdoms of Turkey, Troy, and the fall of Troy. Okay, Homer, Greek poet. Okay, so further, please write further directions. North, northeast, right here. South, southwest. East, northeast. West, southwest. North, northwest. South, southeast. East, southeast. West, northwest. So totally there are 16 directions. 16 directions. Okay. Let's say you have a plot. So in that plot, agricultural land, if you are standing in the center, you can divide the plot into 16 parts. 16 divisions you can make.